Good afternoon, everyone. This is Francis. It's 3:45 p.m. here in Cyprus, Texas, and we're doing a little bit of more telescope work out in Nerpio, Spain, the Astro Camp in Nerpio, Spain, the same place I took my pictures of 433 Eros for the parallax. But today we're interested in what our friends are interested in. Here you'll see in the comment area of one of my latest videos, we have Mr. Terry 428, a friend of mine, and he's asking me about asteroid 2010 KK37. He said after doing the math for the date of May 19, 2012, it comes 0.09 lunar distance from the Earth. So, and that can change and get even closer. So he's interested in this one, and we're going to go find out about it. First, we're going to go to the NEO Earth object list, and here it'll show all the objects that are coming in. And their dates, January 30, 31st, are the ones that came by. And there's 433 Eros. And now we're coming into the next list, which are the ones that are upcoming. And the thing about this, and you can come here, the neo.jpl.nasa.gov site, and see this list. And on here, it goes only till April 18th. So the object that we're interested in, 2010 KK37, isn't on this list, but we can find it here. If you go to the ssd.jpl.nasa.gov site, ssd.jpl.nasa.gov site, you can get the search area here to look for 2010 KK37, and we'll hit the enter, and it's going to give us information on 2010 KK37. I want to come down here and quickly go to the close approach data and just compare what we have. Moon and the Earth, so we have two close approaches as normal to the Moon and the Earth. 2010, 2012. Here we are, Moon, Earth, May 19th, 004, 005, 0009, 00041. To me, that's a pretty close pass. That is not this number. So that is a difference right away. And we'll go here and find out what that distance is. 004. I want to go down to this one. 0009. 0009. That's showing us 83,000 miles from Earth. That's what the ssd.jpl.nasa.gov site says. 83,000 miles. Let's find out about if we can see our magnitudes of 25. Very hard to see something that dim. Check out the orbit diagram. I just want to get a feel for where it's coming from. Very, very dim, 25. Gonna have to do a very long exposure to pick that up. Okay, so what's telling me, let's just see what this says. Let's go to May. Oh, it's going to be coming up. It's below the ecliptic now. Coming up. Meeting right from underneath and coming up. Okay, that's an interesting path. So let's go back to where we are now. March. Okay, so we should, I don't doubt where that position is looking back at it, the sun, hopefully we'll get it. It's 25. I don't know how big it is yet, but let's move on to, here is the information of where it's going to be on certain days of February to February 21st. So at 6 p.m. Central Time, which is 000 hour minutes of the second, 6 p.m. Central Time, 2 hours and 10 minutes away, it'll be at this location. 3:25:12 plus 2 34:48. Now I want to go back. I'm going to get the 1P. We're going to come up here and I'm going to get the information 2010 KK37 from the Minor Planet Center on this page, minorplanetcenter.net. Put in the information, put in the observatory code, which is NERPIO Spain, get the MPC1 line. Let's come back over here and let's acquire the comment. That moon is up. I'm going to go ahead and do that. I'm just going to go ahead and do the 300 minutes. I'm not going to track on anything. Auto log off. We do have the moon up. It's a weird image. The moon is up, but I want to see if we can get it. Let's come back here. Get the ephemeris. There it is. At least that way, Mr. Terry, you have the new coordinates. You can find them here in this video. We'll come back here, drop it. Let's acquire it, see if they'll come up. The run started successfully. We're going to do 5 counts. That's 25 minutes of imaging. You'll see this run through. There's the coordinates again. Well, that's the coordinates of the focus star. Okay, MP elements. There's the coordinates for the object. 032511 23527. And now this imaging run will take a while. We will not even get through one imaging run before the 15 minutes of this video runs out. So I'm going to go ahead and see if we can get one picture in. We probably won't, but y'all can see what I'm seeing at the same time as I'm seeing it. And this is how a telescope works. Plate solve is when they compare the image to a known star chart to be sure that the telescope is in the right part of space according to the coordinates. Once you have the coordinates, you can find a comparable star chart. Once you take your first image with the telescope, they can compare that image, and you'll know that's how they confirm that they're pointing at the right coordinates. They're focusing the telescope. They want to make sure that they have it focused on the depth of space that you want it to be focused on. Because all the exposures are 5 minutes apiece, we will not be able to see one of the first preview images because the video will run out. You'll see that the telescope is now slewing to the object, 2010 KK37. In telescope phrases, it's K10K37K. Using these images again, I can quickly do the astrometry and discover if we're pointing at the part of space that the coordinates are telling us we're pointing at. You'll see and notice that through the process of getting ready to image, they confirm focus. They confirm position of the telescope. It's taking more pointing exposures to make sure that the telescope is pointed at the right place and at the right depth. This imaging run with the five-minute photos will probably take a while. So it'll be a while before we get any images, Mr. Terry, but know that there are people taking pictures of that part of space because you asked and we're interested. And there we are, we're taking our first exposure now, and you'll see that the exposure for 300 seconds is occurring. The guider scope, which you see there coming up, will make sure that the telescope stays with the star field through the entire 5 minutes, and through that process we should be able to absorb as much light reflected onto 2010 KK37 as possible. It's 14.5 minutes and we only have 30 seconds left to this video, so thank you for watching. Here's another how to take pictures of asteroids from Francis Walsh, your favorite amateur astronomer. 4 p.m. Central Time in Cypress, Texas. Y'all have a great afternoon and evening, or morning wherever you are. Goodbye.